Thank you, everybody, for attending today, and welcome to our webinar. Today, our webinar topic is on programmable blankout signs and the evolution of digital signage. It's great to see so many people joining us today, and again, I thank you for taking time out of your busy schedule to attend. My name is Harrison, and I'm the Ontario Account Manager with Remude Digital. So before we get started, so on the right-hand side of your screen, you will have a questions tab. So any questions that come to mind during the presentation, please post them there. And then at the end, I'll do my best to address all questions. And one other reminder, we're gonna have a quiz in the presentation at some point, and it's gonna be based on the material presented. So the first person to answer the question correctly gets the Remude Digital Theme Prize. It's multiple choice, so in the question function, enter A, B, C, or D, and the first person to answer correctly will get the prize. Okay, so getting into the agenda for today. So this webinar is going to explore how advancements in programmable digital signage are reshaping the market for blankout sign applications. We're going to look at the benefits of blankout signage. We're going to look at how it's regulated currently in Canada and Ontario, and how evolutions in digital programmable signage technologies are disrupting the market for the legacy technology, what everyone's been using currently for blankout signs. We'll also look at the future and how, as regulation evolves, we're likely to see more dynamic, safety-focused applications evolve alongside the regulation. And at the end, we'll touch on two unique case studies before we field questions. So for anyone who doesn't know us, we're Remude Digital, right there. Formerly Stinson ITS, and we're part of the Remude Canada group of companies. This group includes Stinson Equipment, Remude Digital, of course, Remude Services, and Ontario Barrier Wall, which is now Remude Rentals. So we're the technology-focused partner in the group, and we specialize on intelligent transportation. So our services, they extend within the group of companies, and we like to help our fellow partners, to support new applications involving technology, to realize greater efficiencies in some of the things we're already doing, and to explore new applications. But we also work directly with our own clients on specific intelligent transportation projects. We are, of course, a full-service turnkey shop. We have internal manufacturing resources, a wide international network of partnerships and trusted industry vendors, and of course, knowledgeable staff who understand the Canadian market and the wide variety of technologies we support. So before we get into the meat of today's discussion, I wanted to start by talking about the evolution of roadway signage in general. So standardized traffic signs, we all know and love standardized traffic signs, and they date all the way back to 19th century Europe. And before then, signage was mostly text. But in the 19th century, pictorials began to play a critical role in overcoming language barriers and enhancing traffic safety. So this marked a big shift from text-based signage to universally understood symbols, which would actually lay the foundation for modern traffic management systems. So fast forward to the 20th century, or the late 20th century, and now we see the integration of LED technology into traffic signs and signals. We've also seen the adoption of LED dynamic signs, which are known as blankout signs when installed at an intersection. And this technology uses a prearranged pattern of LEDs to display a static message when turned on. The reason for their popularity is very simple. The LEDs are much more visually prominent and clearer for drivers to see, giving a weight and importance to the message displayed. Today, technology has evolved even further, and now fully programmable digital signage is disrupting the market for traditional static LED signage. Programmable signage holds several benefits over static signage, including higher pixel counts, higher LED resolutions, superior visibility, and near unlimited flexibility in the graphic or information being displayed. This type of sign can also integrate into a larger intelligent transportation system, opening up the options for more dynamic and unique safety-focused applications. As you may know, Stinson and Remude Digital have been in the programmable signage market for many years. We are a prominent supplier of message boards, smart work zone solutions, dynamic signage, and fixed support signage. We've also been active in staying abreast of advancements in technology. For instance, the little mini VMS you see here is a full color mini VMS, and it's designed to deliver messaging for pedestrians and cyclists, much like a fixed support VMS would for vehicles. This mini VMS over here includes a modular support structure made of concrete blocks, and it's designed to be craned and dropped into places where you couldn't fit a PVMS board, so like the boulevard in a busy downtown corridor. And finally, our true full matrix programmable signs. This is the primary topic of discussion today, and a great example of how previously cost prohibitive technology is rapidly gaining traction in the Canadian market. And this is primarily due to reduced manufacturing costs and features which improve upon existing concepts like blank out signs, and innovations which enable new dynamic safety-focused applications. We'll certainly touch more on programmable signage later in the presentation, but I first want to speak about one of the most common applications of dynamic signage, and that is blank out signs. So for anyone not familiar, a blank out sign is a dynamic electronic sign that illustrates an LED legend, typically for restricting a turning movement during a specific signal phase or specific time of day period. Blank out signs ultimately improve compliance by drawing a driver's attention to the prohibitive movement. And I also came across a very interesting study that was conducted by the City of Toronto in 2014. And this study measured the effectiveness of left-hand turn restriction blankout signs for different time of day periods. So the study was conducted along King Street, and it measured the effectiveness of these blankout signs across a very busy streetcar route. And it was conducted across multiple months. And after fully evaluating the data, the study found that the LBO signs, or LED blankout signs, provided an overall compliance improvement of 48%. So these findings led to blankout signs being a key pillar in the City of Toronto's Vision Zero push. And today, the city has over 100 LED blankout signs in its inventory. So this is a great example of how blankout signs can improve compliance and how they can be used as a very effective safety tool. But it also begs the question, if it's such an effective tool for improving safety, why aren't more municipalities using blankout signs? I came across some other examples of blankout signs being used in Ontario. And the most notable one, which I found the most interesting, was the City of Kitchener and Waterloo region with Grand River Transit, where blankout signs are being used to restrict turning movement phases to prevent vehicles from conflicting with their light rail at intersections. But other than a handful of examples, I was hard-pressed to find other wide rollouts of blankout signs, and adoption levels are relatively low in comparison to the potential safety benefits. And from speaking with our clients and doing a little bit of research myself, it seems to be related to regulation and enforcement of these devices. Regulation in our Highway Traffic Act is very limited when regarding blankout signs, and it honestly feels somewhat incomplete. First of all, only turn restriction signs or lane designation signage may be replicated electronically. So the RB10 all the way through the RB16 and the RB41 through the RB47 may be electronically replicated. And this, first of all, it prevents municipalities from exploring other dynamic safety measures. And one of the most common ones I hear people talk about is dynamic no right-hand turn on red. There simply isn't regulation for it. It's also unclear that if I have a dynamic sign, if a supplemental static sign is needed to be enforceable. So for instance, a lot of municipalities, when they put up a dynamic sign, they have a static sign as well. And so if someone does disobey the blank out sign, the static sign is used as the enforceable sign. Again, this somewhat defeats the purpose of having a dynamic sign, and it really removes some of the flexibilities that you can achieve with their operation. Finally, the last point is according to the way the regulation is written, it states that the image and legend of the dynamic sign must bear the same dimensions and legend as the static sign as practically as possible. So the way the regulation is written, it not only limits the applications that we can use with dynamic signage, but it also calls into question what qualifies as a dynamic sign. If a dynamic sign must bear the same design and dimensions as a regulatory sign, do our current fixed LED dynamic sign technologies satisfy this requirement? You know, one could argue that this LED blankout sign does not bear the same design, color, or dimensions as a regulatory sign, and is therefore not enforceable under our Highway Traffic Act. So with the benefits in mind and the challenges, we're going to examine how traditional blankout sign technologies operate. We'll look at how the fixed technologies operate in our market, and how the evolution of digital signage can not only reduce the gray area associated with enforcement, but also improve the efficiency of large-scale rollouts. So this is a fixed LED sign, and it's the most commonly installed technology for blankout signs in Ontario. So these boards, if you can tell, include a preset pattern of LEDs, which illuminate when the turning restriction's in effect. You can see there's a pattern for the RB10, there's a pattern for the 11, 12, et cetera, et cetera. However, once one of these boards is purchased, there's no way for you to change the preset pattern of LEDs. If you want to restrict a different turning movement than the one board you purchased, you will have to go out and buy a different model with the appropriate LED pattern. So this sort of creates a bit of an issue, most notably with holding spare inventory and managing that inventory, because if I have tens or 20 or dozens of different models of LED boards that are all fixed, then I have to carry dozens of different spare components in case, God forbid, one of these models fails and I need to do a very quick swap. A great analogy for these fixed boards is the Light Bright toy from the 70s. I don't know if you're familiar with Light Bright. I had one when I was a kid. And when you wanted to change the graphic of a Light Bright toy, you had to take the pegs and build your own image. However, there was no way to change that image unless you physically remove the pegs and build another image. So on top of this inherent issue with LED boards, they can't reasonably replicate regulatory signage as it's stated in the HTA. They lack the resolution, they lack the elasticity to, without a reasonable doubt, recreate regulatory signage. However, despite these shortfalls, fixed LED signage was widely adopted in Ontario for blankout applications. Fully programmable options were either cost prohibitive or simply not available. Some audio. Sorry about that. So today that's completely changed, and fully programmable options are, their manufacturing cost has come down greatly, and not only are they available, but their price point is much more comparable to their fixed LED counterparts. And I'll get into now how dynamic, fully programmable LED signs are reshaping the market for this particular application of dynamic signs. Okay, so today, modern programmable signage features a whole wide variety of benefits to the blankout sign application. Higher resolutions, the ability to recreate graphics down to the detail of individual LEDs, and enhancements through modular sizing. The boards we supply are from ChainZone, and for instance, a ChainZone board has an unbelievably high resolution of 10 millimeters. And when I mean 10 millimeters, that refers to the distance between LEDs. So if I have a 10 millimeter resolution board, those LEDs are spaced 10 millimeters apart from each other. And if the board is, let's say, 64 centimeters by 64 centimeters, that board includes over 4,000 LEDs. And unlike other boards or other programmable boards in the same category as ChainZones, where the LEDs may be clustered, which means you can't program an individual LED, you must program a cluster or grouping of LEDs. ChainZone boards support a full, true matrix display. And this means every individual pixel can be individually programmed to recreate the detailed graphics you see below. These boards are also available in modular sizes. So instead of having 1 or 2 or 3 fixed sizes, we can support a wide variety of different sizes to fit almost any application, from, for instance, a mini pole mount travel time VMS to a larger display for travel time messaging on a highway, or event messaging, or the applications like a blankout sign, where we need to be a similar dimension to the HTA regulated signage. Finally, our boards can be controlled in multiple ways, either via NTCIP, where graphics can be uploaded and changed remotely from the comfort of your office, or tied to an AC input, like the load switch in your traffic cabinet, such that graphics and turn restrictions are displayed in conjunction with the required traffic phase, much like how a traditional fixed LED blankout sign would operate. So we've taken this product and we've adapted it to the North American market to make it usable in our municipalities, communities, towns, and really make it simple for the people using the end users of our product. And that's where our value really comes in, is making sure that the products that we're bringing to the market are usable for our clients, and the complexities are removed. And these features are honestly great news for any municipalities considering to get into dynamic signage or blankout signage. With the modern fully programmable technology, municipalities can reduce the gray areas surrounding regulation and fully recreate regulatory signage down to the exact color, pixel and dimension. It's now a lot harder to argue that this digital recreation here I'm showing you of the RB11 doesn't replicate a regulatory sign, or doesn't represent a regulatory sign. Our boards include simple and intuitive tools for graphic design and upload. So now you're empowered to create and change graphics based on your needs and are no longer restricted to the limitations of fixed LED signage. This feature has numerous benefits to overall budgeting and efficiencies. Instead of carrying extensive inventories of every possible fixed LED blankout sign pattern, municipalities can now standardize on one fully programmable sign that can display any graphic or pattern. One final feature I want to touch on again is the modular display, because this is a really cool feature of our boards, and I think one of the biggest differentiators of it in the market is a modular display sizing. Because our boards aren't available in fixed sizes, we can fit a whole wide variety of applications. And right here is how they're built. Each board includes a individual LED module, which is 16 centimeters high by 32 centimeters long. And we use these modules to build out a board, basically. So we'll include a number of modules to fit the size of the application you're trying to size, whether that be a blankout sign, an event sign, or a more rectangular sign that can display signage like the RB79 or the no right-hand turn on or head static sign. And I don't know if I'm sure, like myself, some of you have experienced maybe a little bit of frustration with static no right-hand turn on red signage, particularly during off-peak periods where there's low volume and you're stuck waiting to waiting for the green to make the right-hand turn. And as I mentioned earlier, there's no HTA regulation for dynamic no right-hand turn on red signage, specifically the electronic version of the RB79R. However, as more municipalities begin exploring dynamic sign applications and begin lobbying our government to update the Highway Traffic Act regulation, we expect this type of application will begin to show extensive safety and operational benefits, leading to the regulation evolving alongside technology. And I'd like to think the tools that we're presenting today will help fuel the need for that regulation to evolve. So one more example of no right-hand turn on red. This is a image of our 64 by 96 centimeter display. It's the additional size again is achieved by including 2 rows of LED modules, giving us the additional height to replicate something like an RB79R, which is 90 centimeters high by 60 centimeters long. And you can see here, we can fit that comfortably on our display size and even capture details like the black border of this sign right here. So why I believe this particular size is interesting is that you can, display something like an RB79R. You can also display something like a graphic very comfortably with the additional size or travel time messaging. And it sort of allows you to standardize on a sign size, which will prepare you for the future when things inevitably evolve. So with this size, you could display a 60 by 60 RB11 by centering the image and then disabling all the pixels around the image, but it will also prepare you for the future if you wanted to display something like an RB79R for no right-hand turn on red applications, when of course the Highway Traffic Act is updated. So I want to just quickly summarize what I've talked about today before getting into some more future-focused applications and case studies. And what I really want to hammer home here is the difference between our fixed signs, the traditional signs, and the fully programmable signs. Again, fixed pattern LED blankout signs support a limited number of graphics, typically one pattern. And because of this, you're going to experience a lot of problems with maintaining spare inventory, spare parts, and will likely have a very bloated inventory if you carry a lot of blankout signs for different applications. You will have an issue recreating regulatory signage because your LEDs are inherently fixed and you don't have a full matrix display to work with. They're also limiting sizing options. So you're very pigeonholed into specific applications with these signs. There's more gray area around if they're enforceable. And honestly, it's getting to the point where it's time for the market to move forward and embrace new technologies which are more flexible, like the programmable sign. The programmable sign can upload any graphic, any pattern, nearly any graphic, nearly any pattern, or an animation. I mean, it's not going to say that anything can be upgraded to our board, but it's hard pressed to find something that we can't replicate. We can fully replicate regulatory signage in incredibly high levels of detail, and we can reduce the gray area around enforcement and around citizen comprehension, because this sign is without a doubt an RB79R. It'd be very hard to convince me that it's not an RB79R. And on top of that, another great point is that with one sign that's fully programmable, you will have a lot more efficiency in your inventory. Rather than carrying spare parts for every possible movement of the static sign, you can carry one model and reduce your inventory by 80%. And finally, remember, high 10 millimeter pixel resolution. This is an important fact and will be even more important later in the presentation. So keep that in mind. We have a very high resolution. We're full true matrix, so each of those pixels can be individually programmed. And of course, we can program our boards through NTCP or locally. We're very flexible on how these boards are accessed and used by our clients. And of course, it's an affordable price today. So I want to now just get into a little bit of idealistic future thinking. I know, when I look into the future and when our company looks into the future, we see a reality where safety messaging isn't governed by a predetermined fixed schedule, but dynamically activated by responding to the current safety needs of an intersection. This is going to seem a little far-reaching, but just hear me out while I talk about a unique application that we're actively working on in the market right now. So with new technology today, we can proactively measure safety risk at an intersection using sensors and artificial intelligence, and we can communicate the change in risk to third-party devices like programmable message signs. So the system diagram I've included below is a product we offer. It's called Smart Operations. Smart Operations continuously collects high-resolution traffic data in vehicle trajectories and conflicts in real time at a location like this intersection. So the data is collected through the permanent video cameras, and it's processed locally by a hardened computer in the traffic cabinet. Conflicts or near misses, however you want to call them, are mapped in real time and represented by the heat map shown in the bottom right-hand corner. So as traffic patterns change and the frequency of near misses increases from movements like this right-hand turn here, as I'm highlighting, you can see the clear red spot here, we can dynamically send a signal to a message like this RB79R to restrict the turning movement on the red signal until these conflicts return to the baseline value. So this is a concept, and it's something we're again actively pursuing, where we can, implement safety measures dynamically without jeopardizing intersection efficiency. There's no reason to restrict a red-hand turn movement if it's a low volume off-peak period in the middle of the night. But, again, during a high peak period where there's lots of cross-street traffic, restricting the right-hand turn on red could save lives, and it may prevent some very nasty accidents. The same can be said about other applications. For instance, dynamic pedestrian safety. Sensor technologies exist which can track and measure pedestrians and their movements across something like a crosswalk. And at night, when visibility is poor and when people are making right-hand turns on the red signal, or it's a blizzard and somebody's in a hurry, oftentimes pedestrians can fall into the blind spot of a driver and be completely unseen. So using a technology like an intelligent sensor or smart operations to detect the pedestrians in the crosswalk and send a signal when they are in what would maybe a blind spot for a driver to an upstream VMS to say, watch out, or there's a pedestrian in your blind spot, or provide some sort of safety messaging, which again draws the driver's attention to the message such that pedestrians who are crossing in these blind spots are protected. And this is just another example of how we can use our boards to enhance safety in truly dynamic applications. Okay, so we're gonna have our quiz now. I hope everybody was paying attention. And the quiz question today will be, what is the display resolution of our chain zone fully programmable message boards? So I'm gonna click another button here and it's gonna display all the options for your answer. And please click the first letter associated with this answer in the questions tab.
So we actually had the correct answer before we had the answers up for choices.
I always make that mistake. I should have sent the answers sooner.
You may have been a little bit obvious with your hint, Harrison.
Oh, no. Oh, no.
But the answer is B, 10 millimeters. And Michael from Brant, you guessed it correctly.
Nice, nice. Congratulations, Michael.
First. A lot of people guessed it correctly, but you did it first.
Great. I'm glad everyone was paying attention. That's great. That's great to see. So we're going to end soon. But before we do that, I want to look at a few case studies where we've been working with our clients on these safety applications involving programmable signage. So the first case study is the city of Calgary. Now, I'm not from the city of Calgary, so a lot of this information came from me. She's been working very closely with the city of Calgary on this for a long time, and it was a very interesting use case. So let me provide a bit of context. The city of Calgary, according to her, uses roughly 20 different fixed matrix blank out sign models at their intersections. Again, I couldn't independently verify this, but because the city is using so many of these different fixed variable message signs, or sorry, blank out sign models, they were finding it very inconvenient to deal with the number of sheer spare systems to keep everything updated when systems would inevitably fail. So having 20 unique different signage models means you'd have to carry at least 20 unique spares. That's a lot of inventory for a blank out sign. So after Sherry, our Western account manager, showed the city our fully programmable blank out sign, they were very happy to immediately purchase 3 signs for testing. And ideally, if this sign can pass the rigorous testing the city of Calgary will put it through, environmental, operational, you name it, there is a very good argument to say that these signs could save a lot of indirect cost right off the bat. Instead of carrying 20 unique spares, now you're carrying maybe 80%, maybe less than, maybe 20%, maybe you're carrying 5 spares, but of one single model. So in this case study, the primary focus was let's reduce our overhead, let's reduce our inventory and adopt new technology that will help us save money. But it will also allow you to, replicate and reuse these signs as conditions change, and perhaps use them in different applications. Maybe you can use them for event graphics during special events. Like, they're not restricted with how you use these signs because, again, they're fully programmable and they include a very high pixel density, and of course, they're modular. And the final application I want to chat about today, it isn't directly related to fully programmable blankout signs, but I thought it was interesting to discuss. This is an example of a dynamic safety solution we're working with the city of Brampton, and we call it the world's safest intersection. And that's because we're implementing some very cutting edge technology here, and that's that smart operations product I referred to earlier. And it's a fairly complex project, and the deliverables are staged such that we can perfect, test, and develop functionality as we go along and as we work with our partner, the city of Brampton, to improve intersection safety. So phase 1 is real-time safety monitoring. And that's where we're installing smart operations, installing the cameras, and measuring how the intersection is working currently. And we're going to be mapping conflicts. We're going to be gathering data, and understanding where the hotspots are really, and how that evolves over time. Phase 2 is where we get into active safety interventions, and this is what I was talking about earlier regarding dynamic no right-hand turn on red or dynamic pedestrian warning applications. This phase is where we're going to try to command the intersection to respond to how the safety profile is evolving in real time. And those can include things like dynamic LPI, so not having leading pedestrian intervals running all hours of the night when you don't need them. I'm in Mississauga, and we just installed LPI at many intersections along Dundas and other intersections, and I got to say, I see the benefits of LPI. I love seeing the city improve pedestrian safety, but perhaps there's a way we can make it more efficient. And again, with this phase 2, we're going to be looking at things like dynamic no right-hand turn on red, and trying to get a signal from our change in the safety profile to a blank out sign to restrict movements during periods of high conflicts. As we move into phase 3, we're going to try to implement adaptive signal timing based off of how the safety profile of the intersection is changing. And then as we move into stage 4, it's the optional introduction of RSU and LiDAR technologies at the intersection to improve accuracies and efficiencies. So that is all I have for you today. I hope everybody enjoyed the presentation and found it educational, ideally, and informative. So if there are any questions, Sam, if we have any questions, please let me know. I'll do my best to answer them. If I don't have the answer for you immediately, I'll write it down and get it to you in an email.
We do have a few questions. The first one asked was, are the OTM regulatory signs pre-programmed within the software?
Oh, great question. Yeah, that's of course something we can do for you. So the boards will come to us first, and if you need us to create OTM regulatory signs like we do for a lot of our clients, we will certainly create all the required OTM regulatory signs you need in a library that you can use to upload onto the sign and immediately start using in blank out sign applications.
Someone asked, how are these signs safeguarded from cyber attacks?
Oh, good. A great question as well. I'll have to get back to you on that one, but there is a fairly straightforward answer as well to this. And we do have a modem inside the signs, that's correct, but we can also just remove the modem and have it operating locally in your intersection. We just need to program it for the application you want to use it for, and then we can take it offline and connect it to your traffic controller so it acts as an offline device. But I will look into what safeguards we have if these devices were to include an NTCP modem. Who asked that question, Sam? Or I guess you can tell me later.
Yeah,
Yeah,
I'll send you the
excellent.
list later.
Thank you.
Someone asked again, how can we load the required symbol to the sign?
Yep, no, that's a good question. That's a great question. So we include a web application, or sorry, a desktop application, which includes the chain zone, this, I guess, graphic creation kit. And if you are really interested in learning about this, we can certainly walk you through what the process is for creating graphics and uploading them to the sign. We've done it for our clients, and we can certainly do it for yourself or anyone who's interested, or walk you through it so that you have the ability to create and change graphics of your sign. But it's very simple. It's nothing outside of the norm for traffic technologies. If you're familiar with other software platforms like detection configuration, this is just another tool in your toolbox that you can use to update, change, and modify dynamic sign graphics.
Someone asked, any connection to the power required, or is the sign supported with solar?
A great question. It could be supported by solar, something that we have to look into, and I believe we've done a few of these with solar. Typically, they're connected to AC power because our main focus for this sign was at the intersection for blank-out applications. But again, these technologies have evolved to the point where solar is very much an option. We just have to make sure that the solar system is sized appropriately for the sign. And we are, I want to say we're experts in the solar market. We build a lot of our own solar systems in-house. So I'm sure with our engineers and our project managers, we can find a suitable solar solution that would effectively size for the sign and bring this sign into an offline solar application.
Are the signs programmable from the signal box?
Signal
Like
box.
activating a no right turn to flash during a red signal phase.
Of course, yes. This is these can be they come with 8 AC inputs. So that means you can connect this sign to 8 individual load switch outputs at your traffic controller. So when a phase activates, you can ensure that the appropriate message is activating alongside that phase. So yes, we can and have connected into the traffic cabinet AC input.
Someone asked, can the brightness be adjusted? Sometimes the white can be too bright and distracting.
Great question. I will have to check on that for you. Can brightness be adjusted? I will get back to you on that question. Sam will let me know who to reach out to.
For dynamic safety use, signs changing due to the conflict heat map, is what's shown on the sign tracked at what time and what duration?
It's possible, theoretically, that is possible. We can monitor the input that we send to the sign and then keep a track record of how long that input was activated. So yeah, we can monitor how long the sign has been active for in a dynamic application. And again, this is more of a concept that we're working on. So, as we get more comfortable and more fleshed out with this type of concept, we'll certainly let you know on how it's going and what, moves forward we're making.
In the signs, how many batteries are used and what kind?
Interesting. Right now, the signs are AC powered, so they don't include any batteries. They're just connected to an AC power source. However, if we were to adapt this to a solar application, again, I'd have to check with our manufacturing team and engineering team to figure out what that would look like, how many batteries that would be required, and if we can power it over solar. So I will again get back to you on that question, and of course the solar question as well from the other attendee. How many batteries? And I'm sure there's a record of this. I shouldn't be writing them down. There's a record in the webinar, right?
Yeah, I can send you a report.
Okay, great.
Have you dealt with any issues during a power outage? Is there a fail-safe image?
Good point. Great point. We haven't had any experience with a power outage yet, but I can check and see if there is a fail-safe image that gets displayed in the event of a power outage. I believe that this would be quite hard unless there was a backup, like a UPS that this was connected to. I mean, if the cabinet does have a UPS system, I'm sure we could tie the power source into that UPS, or because we're connected to the cabinet, that when the UPS is active, we should be powered off that UPS. And if you are sizing your UPS applications to keep the intersection active for a certain amount of days, then you should take into account the power consumption from any accessory like a blankout sign, so that when you're purchasing that UPS and battery system, that it's been accounted for. So we can give you power specs on the system, but ultimately a backup power would be the responsibility of the UPS at the intersection. That's what I would believe. But I can check and see if there is a graphic that's displayed or something displayed if the power does end up going out at the intersection.
Are the signs powered driven by the load switch and tied to the traffic controller logic gates?
Yes, that's exactly how it works. That's how it works in our local applications with an AC load switch tied blankout sign. That's how our current signs are operating in the field when they are used at an intersection.
Have we had any issues with ice buildup?
I don't think so, not yet. Again, we still have to get more time with these signs in the field and testing them and understanding where some of the environmental challenges will come from. At this point, I can't comment on ice buildup, but I can do some digging and see if this has been experienced by any of our customers or anyone else out there who are using this sign.
I think that's it for questions.
Excellent. Well, that was great. Again, I thank you everybody for attending today. And just one final note here. This is our information. This is Michael McGuire's email. I should have changed that. But yeah, we're at 80 Royston Road in Woodbridge, Ontario. Feel free to drop by anytime. And it was a pleasure speaking with everyone today. Should you need to reach out to me, I'm just a phone call away, 416-712-5497. Thank you again, and everybody have a great day. Bye now.